Hello, here we are again, another A-level maths video. This one is on Pure Maths Year 1. We're looking at section 3.6 of that textbook, and we're going to look at how we can solve inequalities but using graphs. So let's get you thinking about this idea, shall we? On the screen I've plotted two graphs. I've got the equations up there on the screen as well. I'd like you to pause the video and see if you can get your head around what's going on in this question. All right, let's see what we're thinking. So first question, for which values of x does the red line lie above the blue line? Okay, well, that is going to be the x values which are greater than 4. And if you look, you can see that they intersect, those lines intersect when the x coordinate is 4. And so the red line is above the blue line everywhere to the right of that, where the x values would be greater than 4. Okay, next question, it says, how could we use this result to write down the values of x such that a half x is greater than 2? Well, relating that back to the graphs, half x, that's going to be the y coordinate on the red line. I'll just write that as y red, like that, because of course that red line has equation y equals a half x. The blue line has equation y equals 2, so that 2 there would be the y coordinate at every point on the blue line. So we're looking for where the y coordinates on the red line are greater than the y coordinates on the blue line. In other words, where is the red line above the blue line? Exactly where we already identified. So our answer to our question must be that the solution of this inequality must be all values of x which are greater than 4, and if I write that in set notation with the curly brackets, that's what I'm going to end up with there. So I'm hoping you're seeing how useful it is to look at the graphs when we're trying to solve inequalities. I've put the sort of more formal result on the screen there. I've put it in terms of functions here. So the graph y equals f of x will be below the graph of y equals g of x whenever the value of f of x is less than g of x. And similarly, the graph of y equals f of x will be above the graph of y equals g of x whenever the value of f of x is greater than g of x. So I'm hoping you're agreeing that's not a particularly complicated idea to use the graphs to help us understand these inequalities. Okay, I've put another question on the screen for you to have a go at here. I've already plotted the graphs. I found the intersection point. Your job is simply to write down the set of values such that 3 minus x is greater than 2x. Okay, so hopefully we got an okay with this. Let's just check. So if we want 3 minus x to be greater than 2x, we want the graph of y equals 3 minus x to be above the graph of y equals 2x. Looking at the diagram that's already there, we can see that they intersect when x equals 1, but the 3 minus x is above 2x to the left of that, so therefore we are looking for x values which are less than 1. So all values less than 1 are going to work. Let's put that in our set notation with the curly brackets, and that is the answer we should have got. And there really isn't much more to this section of the chapter. The only thing that could happen is we could end up with slightly more complicated graphs to look at here and slightly more complicated inequalities to deal with. I've put a question on the screen where we've got a quadratic curve and a line there as well. And I'd like you to just pause the video and see if you can write down the answer to this one, please. Okay, hopefully we're getting the idea by now. So this one, we want the curve to be below or in fact equal to the line. Okay, so where is the curve below or equal to the line? Well, the x values there are going to be between -2 and 4. And we are including the endpoints here, the -2 and 4, because we are including in our inequality the fact that they could be equal to each other here. So I need to remember to do that in my inequality. Let's put that in set notation. And I think we're done with that one. Okay then, so let's see how you get on with a question like this. So here I'm asking you to sort of bring in an idea from earlier on in the book, where we actually need to find those intersection points ourselves. So solve some simultaneous equations to find the intersection points and then use that answer together with the graph to find the solution set to the inequality, please. Okay, let's just go through this one together then. So here we had to find those intersection points first, didn't we? I'm just going to quickly sketch the graph here so that we can see what's going on. So our intersection points, I can see we've got one here and we've got one here. And so knowing where those intersection points is going to really help us to solve the inequality that we've got here. But we need to do a bit of algebra to get those intersection points. So let's solve the equation simultaneously. And I can see here that we've got y equals negative 4x plus 1 here. Then in the second equation, wherever I see y, I could write negative 4x plus 1. Let's do that. Rearrange that a little bit here. So I'm going to add 4x to both sides, subtract 1 from both sides. And I've got myself a quadratic equation. Now this one factorizes quite nicely, or you could use the formula, or indeed maybe even your calculator, to tell you that the answers here are going to be negative 5 and 1. So we were asked for the coordinates of the point, so we need to find the y coordinate as well. So I need to do that by substituting in the values of x I've got into either of these equations. And when you do that, you should have got the answer here, negative 5, 21, and 1, negative 3 are the coordinates of our intersection points there. Okay, so let's put those on the graph here. In particular, I'm interested in the fact that the x-coordinate of that point is negative 5, and the x-coordinate of the point there is going to be equal to 1. So the inequality x squared minus 4 greater than negative 4x plus 1, what I need here is I need for the curve to be above the line. Okay, I need the quadratic curve to be above the straight line. And that's going to happen here and here. So I'm looking everywhere to the left of negative 5 and everywhere to the right of positive 1 here. So let's just write that down here. We need x to be to the left of negative 5 or less than negative 5. I'm going to write that in set notation. And that's we want to also collect together with these values over here. So that's in union with the values of x, such that x is greater than 1. And that is my solution set to the inequality. And that really is it for this section of the chapter. There is nothing else that we need to know about here. So hopefully you've got the idea. It's quite a simple idea. I hope you're agreeing with me. But if you do need a bit of extra practice, you can go to exercise 3F in the textbook. That's it for this video though, and I'll see you again next time.